Okay, so we're going to work on the number 5 from last class reflections. Sketch a graph with respect to the function y equal to 4x plus 5 to the cube minus 2 that is graphed after the following transformations are applied. So first we need to plot the given function, which is 4x plus 5 raised up to 3 minus 2. So then we need to plot the domain and plot range. And let's name the plot domain range from -10 to 10 at this time. Okay, so we have this function now. Now we're going to do the first transformation, shift right to units. So shift right to units, the argument is made to x. To right, so the argument made to x, put the parenthesis for x. And now to right, that means minus 2. Remember to put the parenthesis to the x. Otherwise, if you use 4x minus 2, that will make the graph different. So now, second, shift upward 8 units. We add 8 to the y value. So don't calculate, just keep what they are. So now I'm going to end this function. Then we do the transformation. So then we do the reflection. So end this function here. Okay, so we have these two now. They said reflect about the y-axis. So reflect about the y-axis means we need to, this means x value change to the opposite, right? So we are going to multiply x by -1. So let's see what the graph looks like. So maybe we could change the range to be larger, and then we can see more clearly on the top. Okay, so I'm going to change the domain to be smaller. Okay, looks better. Now, class activities, I'm going to put this solution here. Plot a graph of exponential function with respect to the origin. So exponential function, before we do any transformations, we just plot a exponential function. Plot. Okay, exponential function is e to x. Okay, so now we need, before we do transformation, just fill out all the bones, like I said in the class. Okay, name the domain range from -10 to 10 at this time. If necessary, we can make any changes later. Okay, so now the first question says shift left 5 units. That means the argument will made to x. So the to left, that means add 5. Now shift upward, we're going to add 4 to the y value. Okay, before we do the reflection, also I'm going to add another function here. Okay, so reflect about the x-axis. That means the y value changed to the opposite. So we put the parentheses for whole this function. Then we're going to multiply it by -1. Okay, great. So you can play around with the domain or range and make it look better. So also maybe I'm going to change this the plot domain smaller. Yeah, great. You can change the plot range to be larger. Then you will see better. Okay, so next one, sketch a graph or cube function. Say the cube function. Okay, so the cube, I'm going to take this. Then change the function. Okay, so the cube function, just take this. Okay, the cube function x to third, that's the cube. Okay, so now the cube function shift right 2 units. So shift to right, the argument made to x. So then we put the parentheses for x. Then we do the transformation shift right. That means minus. Okay, shift downward 5 units. That's -5 to the y value. See. Also, we'll copy this. Then do the reflection. Reflect about the y-axis. So the y-axis means, reflect about the y-axis means we're going to, the x value should change to the opposite. So we multiply -1 to x. Okay, looks great. Let's change this value to be larger. Oh, even better, huh? How about change this to 10? Good. And we put them in the middle. Very good job. Okay, so the last one, sketch a graph with, no, not last, the number 8, sketch a graph with respect to the function y equal to 3x plus 5 square minus 6. So this is the function we'll refer to. So we first need to plot this function. And 3x plus 5 square, okay, minus 6. This is a function we're going to refer to, and we also need the plot domain and the plot range, filling everything we need. So I'm going to, at this time, just name -10 to 10, and a domain and x from -10 to 10 also. Okay, so the first shift is right 2 units, so that means x will -2. So to be safe, every time if we do the transformation, shift to left or right, that means the argument made to x, always remember to put the parentheses for x. So x is going to -2 to the right. Now shift downward 20 units, just subtract 20 to this function. Okay, so let's say before we do the transformation, add another function here. Okay, so now reflect about the x-axis. That means the y value will change to the opposite. So we're going to put the parentheses for this part, and that means this whole thing will multiply by -1. See what we have? But this means it's better if we can change to the nudge range because we shift downward 20 units and we couldn't see completely the graph in our plot range. So it's better we can change our range to nudger. Let's see 50. Now we're going to change the top to, okay, much better. Now next, sketch a graph with respect to the function absolute value. So this is the absolute value function, and we're going to plot the absolute value function first. Then also put the plot domain and range, and we use unit. So, and also name this -10 to 10, and you always can make change later. It depends your if you, any depends your situation, I guess. So shift left 23 units. Use argument made to x to left and 23. So this is only shifting we need to do. Then we are going to do the reflection. So okay, so we are going to end this one. Reflect about the x-axis, that means the y value will change to the negative. So basically this absolute value will multiplied by -1. Oops. So we did not see any graph. What happened? Here's what happened, because when we did the shift to left 23 units and it is not in our domain. So we're going to change the domain to be larger. Okay, so left, that means we change it to the negatives here. Okay, so we have a the last plot the problem that has zeros, -2 and 3, and reflect about the y-axis. So we know if they have zeros, and we can plug, just use the zeros. And zeros, that means -2 and 3, x plus 2 times x minus 3. So this is the function we need to refer. And now we need the plot domain and plot range. Okay, -10 to 10, x -10 to 10. So this is reflect about the y-axis. That means x changed, right? So the x changed to the negative. Let's have this function here. So we can just multiply -1 or simply just add negative to x. Has to be both to both. Did we shift? Okay, so the reflection did not reflect about the y-axis. Yes, we did. And you can see the reflection. Very good. So that's it.